Okay guys, in this video tutorial we will do the design of member and also connection design. So through design for still member, so you can go to the design menu and then select still member design. So new arrangement of window will appear on your screen. You can see here, let's say we want to you can calculate or do verification for the whole member. Same you can see here, member number 1 to 84 are listed here. So if you want to verify only certain members, you delete this one, and then let's say we select the interior or this beam number 31, click and then bring it here, and then without the SLS, and then let me check the number 31, member number 31, bar list number 31, member number 31. The parameters that this member use, currently it doesn't check the lateral buckling because it is a fully restrained beam. No lateral buckling will be verified. And buckling coefficient, it is will be automatically detect if the member is column. And then so no need to save a new member type. We close it. Okay, so let me run this member, and then for the ULS, check the list. We only use the combination load. Select this one, go here and close this one. The list, we don't need to select all, we only check the member or bar number 31 and close, and then calculate. So here you can see the section 45.7, 152, 52 is okay. The ratio is very small, 0.07, because the load that we apply to the structure is very small as well. So then you can see this one analysis. You can see if any members are analyzed. Okay, calculation node appear here. If you want to have the full node, press this one. So all the detail calculation will appear here with the cause number. Okay, and then close. And then we close this one. It will ask you to calculation result name, member verification, ULS number 31, and you save. Let me check this column, the long column here that we have. Long column here, we have a member that connect to the column about x-axis and y-axis. You see here, about x-axis and y-axis. Also at this point and also at this point. Okay. So verification number 7, and then let me go to 7, and this is a Revit column, the parameters. Let me check the parameters. So here the buckling length coefficient it is 1, but it is for one segment. So since we have in the one segment or one member, we have support condition from this beam that are connected to the column, so then we have to select this. Buckling about Y, add point, so it will attack. And about Z, add point with a join element, so we have this one. And then press OK. Since we have the new parameter, we need to save this one, then save. And for buckling length, coefficient is auto, and save. And after that, we run the calculation. Calculation number has been changed to yes. Then calculation. So also for this column 254, 254, 167, it has a very small ratio, 0.09, because the load that applied to structure also very small. Click this one, buckling here, we'll check. We want to have the calculation node full. Here, check lateral buckling parameters for the buckling here. Clause 6.3. It's very small here for the cross section, and the section is okay for the lateral buckling parameters. And close. And then calculation result name, member verification, ULS number 7, save. Okay, that's all for the member design. You can play around with other members. Let me continue to the design of steel connection. So the new arrangement of window will appear on your screen. So let me set it the section shape into normal one. Let we have the beam to beam connection from this beam and then this beam. By shift button, select. So we select these two member and then press this new connection for selected bars. Select this one. So it will give you some. It will give you proposals. Type of connection that you want to design. So here, beam to beam web connection. It detect and the geometry, and then connection element. You can set it's a plate, thin plate, or angle, double angle. The section already there, so you can change all the parameters here. You can also view how it is look like. The connection view so like here like this. So it is double angle web clad. This is the angles. If you want to set it only single, distance, section, geometry, angle, shape plane for all bolt stiffener, bolt angle here, member right, member left. So angle here at the center, connected to the beam, bolt connection, section position, then the geometry, beam to beam web number 1, plane, bar number this one, the angles. Okay. And then if the position is not at the center, you can set. And this is the length of the equal angle. EQA, we use here EQA 110. You can change also the material. You can change S275, and then for section angle, bolt, the size of the bolt also you can change. Let's say M16 and 4.8 at the center. Vertical spacing. Shape plane at untreated portion. Also same here. M16 4.8 distance center. Okay, and then apply. Okay, you can see the view of the structure, how it's look like. Then after that we verify the design connection. So design of connection from a structure. So then all the result from the structural analysis will be captured here. List load cases, only combination. Then we do calculation. So this quite small, 0.06. Okay, you can play around by changing the bolt size instead of 16 to let's say M10. Also M10 here, smaller one. Apply. Okay, the result will become outdated. The connection will look like this, and then run the analysis calculation. So increase the ratio. So then even you can use a smaller size of the what do you call it, the bolt. Verified all the what do you call it, result calculated here. Okay, that's all for the design of member and design of connection. You can move into the what do you call it, geometry view by select this one, structural model and geometry. So currently we do this one, connection design and member design. So that's all for this video tutorial, and on the next video tutorial we will discuss on how to prepare report. Thank you for watching.